For the question 1, for the data given below, find the interpolated value of current at V equals to 5 volt using Lenzkrangian and Newton's divide difference methods. Compare your result and conclude your findings. So this is the table and the question 1 to find current when voltage is 5 volt. So for the Lagrangian, here is first order, which is we can use formula, which is here. This is the formula, and then we can assume here V1 as 5, V2 is 6, and put the number, and we got 4 milliampere. For the second order here, we also have formula for second order, and then here we assume that V is equal to 5, V1 is 4, V2 is 6, and VO is 2. And the answer will be 4.013 milliampere. For the Newton's divided difference, for the first order method, we can use this formula, and then we put the number of I and V. So from the formula, we can assume that V is 5 and VO is 2. We put it together, we complete it, and we will got 4.05 milliampere. For the second order method, here is the formula. We put the number into the formula, and the answer we will got is 4.04 milliampere. And then here we can say both Lagrange and Newton methods give answer for and only differ plus minus 0.03 that acceptable for calculations.
Now we continue with the question 2, which is compute the energy stored in the capacitor using E, the integrate 10 and 0 PV dV, where P equal to VI by using two numerical methods. And here I use two methods that I get, which is trapezoidal rule and Simpson rule. Let's continue with the trapezoidal rule first. By the given data in the question 1, we use to find the power, which is volt times with the I, which is current. For each one, we will get each power from the data given, and from the data, we see they have n equal to 5, and b equal to 10, and a equal to 0. And by using the formula b minus a over n, we will get the h. This h we will use in the trapezoidal rule, which is here. They have formula for trapezoidal rule, and each power we calculate before, key in the power in the formula trapezoidal rule, and the answer is we will get 271 millijoule. And let's continue with the Simpson rule. By using Simpson rule, this is the formula for the Simpson rule, and we change to the power. And from the table below, from the table before, we have each power will calculate and key in the each power in the formula by find the odd, odd power and even power. And here we will get the answer is 223.06 millijoule. And they have a big difference, so we make the comparison. Trapezoidal rule is simple and generally less accurate, and Simpson rule is usually more accurate at it approximate the curve using parabolic arcs. The significant difference suggests that the function PV is nonlinear and higher order fitting. Simpson rule gives a better approximation.
Next, we continue with the question 3 with the given equation as below. with the value of R. For R is 10 kilo ohm, C is 100 microfarads. Find V for 1 second using two different methods for ODE when the step size is hash is equal to 0.1. Compare your result and conclude your finding. For the Euler method, we are given the first order differential equation for an RC discharge unit is dV over dt plus V over RC equal to 0. Hence, dV over dt equal to negative V over RC. Then we need to find the RC, where is RC is equal to 10 kilo ohm multiplied by 100 microfarads, where is equal to 1. Then we substitute into the differential equation. So dV over dt equal to negative V over 1. So we simplify as dV over dt equal to negative V. So for the Euler equation, Vn plus 1 equal to Vn plus hash times function of Tn Vn, where is function of Tn Vn equal to negative V. Then we need to find the voltage at T equal to 1 second using this formula. So for the calculation step, using the formula above, starting from V0 is equal to 10 volt, we apply the formula 10 times. Sin t is equal to 1 second and hash is equal to 0.1 second. And then for the final step, where is step 10, we will get the value of V is equal to 3.4868 volt.
So for the next method is the Runge-Kutta fourth order method. So for this method, we will use the Vn plus 1 formulas as well as the K1 till K4 formulas. So for an example, we will use step 0 to find the K1 to K4 values, which K1 will be negative 1, K2 will be negative 0.95, K3 will be negative 0.9525, and K4 will be negative 0.945. Next, we can obtain the V function for the first step, which is V1 equals to 9.0484. Hence, we can generate a table from step 0 till step 10 with respective variables. So next is the generated table for step 0 till step 10. Hence, we can get the VIS values, which is equal to 3.678. But for the exact solution will be VT equals to 3.679. So let's do a quick comparison for both of these methods. So for Euler's method, the VIS is 3.486. However, for RK4 method, the value is slightly higher, which is 3.6788. For the error, the Euler's method is slightly higher by 5.22%, but the RK4 method, the percentage error will be 0.005%, which is low compared to the Euler's method. So in conclusion, from this solution that we obtain from this question, the RK4 has a very low error value and high accuracy answer, but the solution is far more complex and it will make the mistake and it will make a high mistake chances than Euler's method. For Euler's method, it has a simple step to be done, but the answer has a very high error percentage compared to RK4. Since we can learn from that conclusion, so the best choice will be RK4 method since it's prioritizing the accuracy in engineering daily solutions. Thank you, and that's all from us.